While IGMP allows the end station and the local switch to communicate multicast information, DVMRP allows the different switches to exchange multicast information with each other. DVMRP allows the different switches to exchange information about what IP multicast addresses each one requires. In addition, the switches need to determine which switch is the originator of each multicast message, because this allows switches to determine the best way to get each specific message. The DVMRP process works this way. A switch receives a multicast message from one of its attached stations. When a switch receives a new multicast, it forwards the message out to all the other switches. These switches in turn either do nothing and continue to receive the multicast messages, or send what's called a Prune message to the switch. And the Prune message essentially says, "Don't send me that message because I have no stations requiring it." Based on this process, the network switches quickly learn which switches need to receive the message and which do not. A switch can begin receiving a multicast message after being pruned by sending a graphed message. The switch generates a graphed message when it receives an IGMP request from one of its attached stations. The graphed message tells all the other switches that that particular switch wants to receive that multicast message in the future. You can think of the path that multicast messages travel as forming a tree. As switches exchange prune and graphed messages, a tree structure of switches forms within the network. The source of the message is the trunk of the tree, and all the other switches are the branches. The tree constantly changes as prune and graphed messages add and subtract switches and end stations from the multicast traffic flows.